failed her. I'm just kidding. Okay, so angle bisector or I can't think of the other one. It's not line. That doesn't sound right. Segment bisector. That's what it is, which is a line. Anyway, those mean they cut in equal parts. So this says that this angle is bisected. So if we know, we'll start with this part. If we know that AC and BC are congruent, that was given to me, and we know that ACD and BCD are equal. Okay, does everybody see that? So you know these two sides and you know those two angles are equal. We're good so far? Then let's see what information we can tell. We know that CD and AB are perpendicular. What does that mean? What does perpendicular mean?
90 degrees.
They make 90 degrees. We know that CD and AB intersect at 90-degree angles. That's right here. We would know that that's 90 degrees. That's what they drew right there. And guess what else we would know? That these two pieces are cut into two equal parts. Okay? So if you know that the legs are the same and the angles up here are the same, then these are the same and that's 90 degrees. That's all this theorem is. They don't have a name for it. It just says the line is the perpendicular bisector. It means it's perpendicular and it splits it into two equal parts. This right here would be a perpendicular bisector. Maybe that's what they call it. Perpendicular bisector theorem. It's a lot. Do we kind of get that? We're about to use it. Maybe when we use it, it'll help. Using algebra. Okay, are we ready for this? So if the sides are the same, it's isosceles. Base angles are the same. If the sides are the same and then a line splits these angles, then the two lines down here are also the same. So, okay, let's keep going then. Let's do some algebra with it. It says, what is the value of x? Let me see where that angle is, first of all. Okay, I can figure this out. All right, it says this angle right here is 54. It was kind of hard to tell. That's the angle, that's 54, okay? I know these sides are the same, so if this is 54, what's this angle right here? What's this angle right here? 54, because the sides are the same, those base angles are the same. Okay, do we know what this angle is right here? We do. Since this is equal and these are equal, what's the measure of this right here? 90 degrees. Do y'all remember we just learned that? That's supposed to be square. That's 90 degrees. Let me just start over. There, that's 90 degrees. Everybody good with that? Now, how do you find x?
90 plus 54 minus 90.
Very good. 90 and 54, and you take it away from 180. So what is x going to be? What is 180 minus 90 minus 54?
36.
36. Everybody good with that?
That sounds pretty easy.
Seems pretty easy. Let's see. Let's look at another one.
What was the answer?
36. We did 180 minus the 90 minus the 54, and it left us with 36 for x.
How'd you get minus 90?
Because remember what we just learned was if this side is the same and these angles are the same, then we learned that this is 90 degrees. Automatically know that. And I know that these two pieces are equal, but that doesn't help me here. That doesn't help me with this problem. And I know since these sides are the same, let me erase this. Since these sides are the same, I know that these two angles are both 54. So we know all the angles in a triangle adds up to 180. So that's all we were left to see. This was 54. This is 90. I just need to know that last angle. So I take them away from 180. Okay, let's see another one.
So would each one of the triangles equal 180, or would the whole triangle equal 180?
All three triangles add to 180. Doesn't matter the size. So you've got three triangles here. Okay? This little triangle, this is 90, this is 54, this is 36. They add to 180. Look at the triangle up here. Totally different triangle. That's 54. That's 90. Guess what this one is? 36. They add to 180. Well, look at the whole triangle. That angle is 54. This angle is 54. This is two angles each at what? 36. Isn't that what we said? 36. Got to add both of those angles. If I add all that up, guess what it adds to? 180. The big triangle would also be. So it doesn't matter what triangle you look at. All three angles in it would be 180 every time. Okay, let's look at another. Actually, that's all of that one. So, I already taught that. Oh, the next thing, the last thing we're going to learn, which we kind of already learned it today. I taught it at the very beginning. It's about equilateral. Oh, I did spell equiangular. I could not find that a minute ago. It's about equilateral and equiangular triangles. If all the sides are the same, then all the angles are the same. If all the angles are the same, then all the sides are the same. What are all the angles? They're equal. And what is their measure?
180.
They all add to 180,
60.
and so each of them measures 60. Okay, all those things were correct. I was trying to get to 60. But yes, all those things were correct. Do y'all understand that? If all three angles are the same and they add to 180, they have to be 60. There is no other number that I can add 3 times and it gives me 180. And it's the same number. 60 is the only number that I can add 60 and 60 and 60, and it would be 180. Okay? If it had to be the same exact number. So, if they're equiangular, they're all 60 degrees. Every time. There is no other number that would work. So, then we are on our last problem. Yay. Is this bad today? I'm hoping it kind
I've
of...
already learned all of it.
You have?
From somewhere. I don't know.
I'm going to see... There's got to be another algebra type problem. I'm sure that's going to be on your paper. And okay. What? I think I have 2 different types of practice problems. Yep, I need to go over that one. I think what I'm going to do is stop here. Make sure I touch on the things that are on your paper today, because and then we'll have a paper tomorrow. That one's kind of tough. I think you can figure it out. Okay. All right. Oh, that one's good. All right, are we ready to look at a few more little problems? Y'all will be great with number 1. I need to look at 2 and 3. Okay. Let me find one like this. Okay, we're about to do this problem here. Please make sure you write this down, and so you don't have to ask me how to do number 2. Number 2 is this way, and number 3 is a different way. So please make sure that you write this down. So you're going to write down number 2 on your little notes right now. So when you get to your number 2, you don't have to ask me how to redo this. Okay? This is where notes come in handy. So we need to learn how to take notes. Now, if these sides are the same, then what do I know about the base angles? They're the same. So I have x, and then that one's also going to be x. Is everybody good with that? I just need to find them.
That's it?
Yeah, so, well, no, but I have to find the value. So if that's x, then I also know this one's x. So first thing I need to think of is, what do all 3 of those angles add to?
180.
180. Well, this one is 30, so let's take that away. What's left over? What's 180 minus 30?
150.
150. So I have 150 degrees left, and I need to split it
75.
between those 2 angles.
75.
So they're 75 degrees. You just divide it by 2. And you have split it. And make sure it works. It's 75 plus 75 plus 30. 180 it is. Another way to have done it is just to say 2x's plus 30 equals 180. Is everybody okay? That's another way to do it. That's algebra. It's saying I have two x's and I add them to 30 and they would all equal 180. How do you solve this? Subtract 30. Isn't that what I did first? I subtract 30. So you get 2x equals 150. Then what do? Which is the same thing I did. And you get 75. So that's the algebra way. Okay, is everybody good with number 2 on their paper? You know. What don't you understand, Cleveland?
The second one.
This one or this one?
B.
Oh, I'm not doing B. Just A is the one like number 2. Okay, I'm going to find one like number 3. Let me look. I'm going to make sure this one where X is at the top of the angle. Surely there is one. I might just have to make one up. Let me make one up. All right. What if I have, this one's different. This one's actually easier. This is like number 3 on your paper. So I'm going to do number 3. And you're going to write this down so that you have it in your notes so that I can not have to have this on the board. So your number 3, it says, okay, find X. And I know that this angle is 34. How would you find X? What would y'all do on this one? We did one kind of like this already, I think.
Yeah.
It is. The other angle is 34.
And then
So
34 plus 34 is
68. And so you would take it away from 180.
so it's
I made this up. I don't know. What is that? 112. Yeah, it's 112. It's just 112. You don't split this one. Yeah. So see, 2 and 3 ask for 2 totally different things. Do y'all see how they're different? Problem 2 on your paper is different from problem 3. Let me see what else we have on your paper. These 2 numbers. Okay. That one and that one are... Do I need to do another one like number 2? Because there's 2 more of those on there.
that was easy.
That one was easy. You just subtract and then divide it by 2. Do y'all remember? Y'all are good with that. Okay. The next thing is, let me see if I can find a word problem like it. This is a great word problem. It talks about an A-frame house. Do y'all know what an A-frame house is? Do y'all remember the old Whataburgers? They used to look like, if y'all go on 71, there's an A-frame house not far from here. It looks like this. That's an A-frame house. Right. Well, they kind of remodeled it. It's by south of Foster Campbell's house. Do y'all know where Foster Campbell lives on 71? No. Y'all don't know who Foster Campbell is?
There's one over there by Camp Joy.
Camp what?
Camp Joy.
I don't know where that is.
Never heard of that in my life.
Where? Listen up. Okay. But anyway, you'll see, look for them. They're an A-frame house. And the Whataburgers used to be A-frame. They've changed them. Anyway, like a triangle. That's an A-frame house. You know the letter A. That's the letter A. Okay. So you have an A-frame house. Let's just draw the triangle. That's what it looks like. This is your word problem, so I want you to get used to drawing it. And it says the 2 congruent sides extend from the ground. Okay, this makes sense. If you're building a house, wouldn't you want the sides of it to be congruent? That's very important, yes. So you're going to know it's isosceles. They're going to be congruent. And they extend from the ground to form I'm going to make this up, 28-degree angle at the peak. Where would that be?
Very top.
Very top. This would be the peak. They form a 28-degree angle. What angle does the side form with the ground? So what's left to find? Either one of those. Does everybody understand that? This is the same thing we did like number 2. So we would do, what do we do on this one? What are my steps?
You minus 180 or
Yeah, minus the 28 from 180. What is that?
152. 152.
Okay.
And then you split that in half.
And then, yeah, you got to split that into both of these angles because they're equal. So you would,
76, right?
seems right, 76.
Yeah.
Yep, thank you.
Not
So
right.
they're 76 degrees. Does that make sense, y'all? So the hard part is people get confused on the whole A-frame house thing. What, is that on the railroad?
It's a truck on a railroad.
Okay, yeah. All right, then number 8 on your paper, that'll probably be our difficult one. What time do we get out of here?
41.
Oh my word, we're not having time. might have to do that one tomorrow. But I did do most of our lesson. I'm gonna make these copies real quick, and tomorrow's. I'm gonna run down there, and we should finish both of these lessons tomorrow because tomorrow's lesson I'm pretty much just about done with it. So let me run make these copies, and you can start on it though, because you'll have. I think you're gonna have maybe.